Good morning, students. Today's topic is logic family. We have seen a number of gates up till now, that is basic gates, universal gates, and special purpose gates. All these gates are having Boolean equation, specific symbol, and according to Boolean equation assigned to them, they produces output. Now all these gates are available in the form of ICs. Now all of you know what are the ICs. ICs are integrated circuits on which we can build any passive as well as active circuit, or we can say that in integrated circuits or on integrated circuits we can able to mount a number of electrons together. So these integrated circuits used because they are reduces the unnecessary wirings on a circuit board, right? So these ICs, integrated circuits, we have seen in basic electronics, and whatever gates we have learned up till now in digital electronics are available in the form of ICs, right? Now these ICs of logical gates uses some logic, that is unipolar ICs or bipolar ICs. Means your gates are available in the form of ICs, but inside that logical gate it uses some logic, right? That's why it is called as the logic families. Now what is a logic family? A logic family is digital integrated circuits, or we can say that it is a group of electronic logic gates uh, which we are using to build digital circuits, right? So these all gates are available in the form of ICs, and each IC uses a different logic, that means unipolar or bipolar logic. So what is a unipolar and bipolar logic? We have seen in basic electronics, if the device or if the logic is bipolar, means it produces the current due to minority as well as majority charge carriers. And if there is a unipolar devices, or we can say that if we use a unipolar logic, it means it produces the current due to only majority charge carriers. So in basic electronic we have seen that what are the bipolar devices. So transistor is a bipolar devices, and unipolar means MOSFET, diode, these are the unipolar devices. So what is the use of using this logic in digital ICs? If you are going with bipolar logic, then it will produce a high switching speed, and if you are using a unipolar technology, then it will produce very low speed, right? So if we consider the speed point, then we will use or we will refer a bipolar technology, right? Now bipolar means it uses a transistor, then diode, then resistor devices to build the technology. And if we are using a unipolar technology, then it will uses only MOSFETs, right? So according to design, according to our specification, we'll choose either bipolar circuit or unipolar circuit. Then we'll mount this bipolar or unipolar technology in our ICs, and we'll use these ICs as a logic gates or logic gate design inside our digital circuit, right? So there are mostly two types, as I said you, bipolar and unipolar logic families. Under bipolar, again the technology is divided into saturated and unsaturated types. So saturated means if we are using a transistor, it will goes into three states, that is a cutoff, saturation, and active region. So if you are using a transistor, you are grounding all the terminals of the transistor, it will goes into the saturation. Now what do you mean by saturation region? It will hold the high voltage at the output side, though there is though we remove input from transistor, it will produce a high voltage level. So using a bipolar saturated technology will give you high output. That means high output means you'll get a high gain at the output side. So while designing these logic gates or logic gate digital ICs will refer a bipolar saturation technology, which generally uses a transistor diode logic, right? So now these logic families means these digital ICs have some characteristics. On that characteristics, we'll select these ICs for designing purpose. From that first characteristics of these ICs or logic families is speed. Speed is very important because if we give input at that time, will require at that instantaneous time will require output. So if there is a zero delay between input and output, we can say that it is having a good speed, a good amount of speed. So speed is nothing. Speed is one of the most important point in our characteristics. Then fan out. Fan out means one digital ICs contains number of logical gates, right? And without disturbing, it will produce output. So number of logic gates will produce output amount, which is called as a fan out. And what do you mean by fan in? The number of input components you are mounting on your digital ICs, and that number will shows you fan in. Then power dissipation. Power dissipation means this point also we have seen in filters and rectifiers in basic electronics. Power dissipation means while doing operations, a digital ICs produce some amount of heat inside it. The amount of that heat is called as a power dissipated at the output side. Then propagation delay, as I said you, when we apply the input to digital ICs, it will produce output. The delay between input and output is called as a propagation delay. प्रोपेगेशन डिले जितना कम होगा उतने आपका आईसी का स्पीड ज़्यादा होगा. सो विल ट्राई टू डिज़ाइन दैट देयर इज़ अ मिनिमम टाइम in between, or we can say that we can design a minimum time between input and output. That means we have to design a minimum propagation delay, right? if अगर आप input दे रहे हो और उसके बाद बहुत टाइम के बाद अगर आउटपुट प्रोड्यूस होगा तो वो अपने ऑपरेशन के लिए फिजिबल नहीं होगा. तो हमको क्या चाहिए? इंस्टेंट आउटपुट चाहिए. जैसे कि हम कोई भी इनपुट दे रहे हैं तो उसका इंस्टेंट आपको आउटपुट लगेगा, तो इसके लिए प्रोपोगेशन डिले आपका कम होना चाहिए. सो प्रोपोगेशन डिले इज़ वन ऑफ द इम्पॉर्टेंट कैरेक्टरिस्टिक्स ऑफ योर आईसी. देन नॉइज़ मार्जिन. जो कोई भी इनपुट सिग्नल आईसी इज़ प्रोसेसिंग, देन सम unwanted signals are produced inside the IC, which is called as a noise. So that noise should be minimum, because if noise is present inside your IC, your IC will not function properly. That's why we have to design a noise margin, which is a figure of noise. We have to keep very less to give the better functionality for your IC. So your noise margin should be always less. So these are the some characteristics for ICs, that is speed, fan out, fan in, power dissipation, and propagation delay and noise margin, right? Now your screen you can see there is a one resistor transistor logic is shown. That resistor transistor logic comes under bipolar saturation technique, which is used inside your logic gates. So it will provide you better speed with resistor. Circuit diagram is also shown, and this circuit diagram of transistor and resistor together is called as a resistor transistor logic. It always uses or it always works like a NOR gate. So NOR gate means if any input is high, it will produce a low output. So if you want a high output, you have to give both the inputs are low, right? That's why the two transistor logic is used here. If any one input is low, if any one input is low, you can see that both the emitters of the transistor is connected to ground. So if any one input is low, it will produce a high output because it uses a VCC supply at the output side, right? If any one input is high, then one of the transistor will go into a saturation, or you can say that it will goes towards a cutoff region. Then it will produce a low output. So if you require a high output, you have to give the zero output to the both the to both transistor. Then and then only it will got the collector supply at the output side, and it will produce a high output. If any one transistor is with high input, then one of the transistor will goes into the cutoff region, and automatically it will produce a low output. So it is like a NOR logic. So if you use a uh, resistor transistor logic, then it will behaves like a NOR gate, right? Then next technology is diode transistor logic. In diode transistor logic, you will find there will be a with the help of this logic, you can design a very less propagation delay. Also, noise margin will be low by using this technology, that is a diode transistor logic. Now this logic always work like NAND gate, means if any one input is low, then it will produce a high output. If you will give both the inputs are high, then it will produce a low output, right? So you can see that at the input side the two diodes are connected. So if any one input is low, then it will acts like a forward bias, and it will it will produce the output voltage which triggers the transistor, and it will produce a high logic. If both the inputs are high, then the two diodes will goes into a reverse bias, and it will not produce any output voltage, and it will not send any output voltage at the base of transistor. So transistor will remain off. So it will uses a NAND logic. So with the help of diode and a transistor, we have designed a NAND logic. So because of use of transistor and diode, combination of diode and transistor will give you lowest propagation delay, as well as it produce a low noise margin. So it is very good technology to use in your digital logic families, or you can say that in integrated circuits. Then next one is a transistor logic, that is a TTL logic. It is also very famous because it produces very high speed. So in our laboratories, the ICs we are using uses a TTL logic, that is a transistor logic. So on your screen you can see that the three transistors are connected together, which is called as a transistor logic. Only transistors are used in this circuit, no diode and resistors are used here. So these transistors produces very high switching speed. That's why this design is very popular. All laboratory use, we always use this logic, that is a TTL or transistor logic. So it will also produces the NAND functionality. NAND means if any input is low, it will produce a high output. If both the inputs are high, then it will produce a low output, right? So for producing high output, you will require one of your input should be low, right? So you can see that the two inputs are given to the two transistors which will produce a high output. If any one input is low, that means if any input connected toward the base of any one transistor is low, then it will produce a high output. Means you can see that if we are providing zero output to the first transistor's base, then it will goes into the cutoff, and the voltage at the collector of the cutoff transistor will provide emitter voltage to next transistor. So next transistor will goes into the saturation state, means it will produce a high output. So at the output side finally we'll get high output, right? So such type of logic is used here. Only transistor is used, that's why the switching speed is very high. So we'll use a TTL logic everywhere, or we can use a digital logic families or digital ICs which uses a TTL logic, right? Then emitter coupled logic means this logic also uses a transistor, but the transistor configuration or transistor biasing in the form of emitter coupled, which we have seen in basic electronics. Here on your screen you can see that all the transistors are with emitter coupled logic. That means the emitter of the transistors are connected together, and with the help of resistor it is grounded, right? So this such type of configuration uses a NOR logic. NOR logic means if any one input is high, then it will produce a low output. For the low, if both the inputs are low, then and then only it will produce a high output, right? So emitter follower emitter coupled logic we are using because will require a high voltage gain. So that's why we'll using emitter logic, right? So this is the diagram for emitter coupled logic. You can see that here also the transistor, resistor and diodes are used. So this is called as, all the transistors are connected in a common emitter configuration, that's why it is called as a emitter coupled logic, right? This configuration is used to improve your voltage gain, right? Your output voltage gain means we want a high output. In that case we'll use this emitter coupled logic, right? Then we have seen RTL logic, TTL logic, right? RTL logic, TTL logic and emitter coupled logic. All these configurations are from bipolar saturation logic family, because the switching speed is improved with the help of RTL technology. Then propagation delay and noise margin is maintained in low amount with the help of TTL logic, and emitter coupled logic is used for high voltage gain. So all this technology are we are using while designing our logic families. Now, what do you mean by logic families? All the gates are connected with some different technology is called as a logic families. So your all gates are attached with this technology, right? Your gate, your universal gate, basic gates, special purpose gates are built up with the help of transistor, diode and resistor logic, right? Inside your logic gates these electronic components are present. So basically these are using a saturated or unsaturated bipolar technology, right? So these are all about your logic families. We'll provide your handwritten notes regarding this topic. Listen carefully, and if there is any question you can ask me on your subject group, right? Thank you.